coffee is unique among artisanal beverages in that the brewer plays a significant role in its quality at the point of consumption. In contrast, drinkers buy draft beer and wine as finished products. Their only consumer-controlled variable is the temperature at which you drink them. Why is it that coffee produced by a barista at a cafe always tastes different than the same beans brewed at home? It may be down to their years of training, but more likely it's their ability to harness the principles of chemistry and physics. I am a materials chemist by day, and many of the physical considerations I apply to other solids apply here. The variables of temperature, water chemistry, particle size distribution, ratio of water to coffee, time, and, perhaps most importantly, the quality of the green coffee all play crucial roles in producing a tasty cup. It's how we control these variables that allows for that cup to be reproducible. How strong a cup of Joe? Besides the psychological and environmental contributions to why a barista-prepared cup of coffee tastes so good in the cafe, we need to consider the brew method itself. We humans seem to like drinks that contain coffee constituents, organic acids, Maillard products, esters, and heterocycles, to name a few, at 1.2 to 1.5% by mass, as in filter coffee, and also favored drinks containing 8 to 10% by mass, as in espresso. Concentrations outside of these ranges are challenging to execute. There are a limited number of technologies that achieve 8 to 10% concentrations, the espresso machine being the most familiar. There are many ways, though, to achieve a drink containing 1.2 to 1.5% coffee. A pour-over, Turkish, Arabic, AeroPress, French press, siphon or batch brew, that is, regular drip, apparatus, each produces coffee that tastes good around these concentrations. These brew methods also boast an advantage over their espresso counterpart: they are cheap. An espresso machine can produce a beverage of this concentration, the Americano, which is just an espresso shot diluted with water to the concentration of filter coffee. All of these methods result in roughly the same amount of coffee in the cup. So why can they taste so different? When coffee meets water. There are two families of brewing device within the low concentration methods: those that fully immerse the coffee in the brew water, and those that flow the water through the coffee bed. From a physical perspective, the major difference is that the temperature of the coffee particulates is higher in the full immersion system. The slowest part of coffee extraction is not the rate at which compounds dissolve from the particulate surface. Rather, it's the speed at which coffee flavor moves through the solid particle to the water-coffee interface, and this speed is increased with temperature. A higher particulate temperature means that more of the tasty compounds trapped within the coffee particulates will be extracted. But higher temperature also lets more of the unwanted compounds dissolve in the water too. The Specialty Coffee Association presents a flavor wheel to help us talk about these flavors, from green vegetative or papery musty through to brown sugar or dried fruit.